Welcome to today's lesson, which is about adding and subtracting to solve problems. So the goals of today's lesson really include the goals from the lesson so far in this unit, where you saw that you drew models, organized information so that you can clarify what you need to calculate, write equations to represent problems and solve them, and solving problems that involve adding and subtracting, especially rational numbers, including fractions, and that you can write your answer in a sentence. So here we have a problem where John lives 1.5 miles from school. Archie lives 3/4 of a mile from school. Who lives further from the school? How much further? So I'm going to draw a model here. I'm just going to draw kind of almost like a number line, and I'm going to start at 0 and I'm going to have the school here. This is the school, and I'm going to go in fourths because I have fourths and halves. 1/4, 2/4, 3/4, 1 mile, and then 1 1/4, 1.5, 1 3/4, 2 miles. And John lives 1.5 miles from school. So John lives here. And Archie lives 3/4 of a mile from school. So Archie lives here. And I can see from the model, without doing any math, that John lives further from the school. And I can see that to calculate the difference, because I want to know how much further, I need to subtract the distance Archie lives from school from the distance John lives from school. So John lives 1.5 miles from school. So I'm going to say John 1.5. Archie lives 3/4. So I want to know the difference between the two of those. So I need to do a subtraction problem. So I've organized my information here so I can see that I need to subtract Archie's distance from John's distance. And they're both mixed. John's distance is a mixed number, so I need to write them as improper fractions. So I'm going to work down here. I'm going to say John is 1.5, which is 3/2, and I need to write it as fourths because Archie's distance is in fourths, so that's 6/4. John lives 6/4 of a mile from school. Archie lives 3/4 of a mile from school, so I'm going to subtract 3/4 from 6/4, and I get that the difference between them is 3/4 of a mile. So to come back to my question, who lives further from school? John does. How much further? 3/4 of a mile. And to put the answer in a sentence, John lives 3/4 of a mile further from school than Archie. Here's a question about rainfall. So far this season, it has rained 3 2/10 of an inch in San Francisco, and the normal season's rainfall at this point is 12 3/10 inches. How much less than normal has it rained this year? And write my answer in a sentence. So again, I am going to draw a number line. Actually, I'm going to draw it vertically this time. So this would be 0 at the beginning of the season, and now in San Francisco to 3 2/10, say it has rained 3 2/10 inches, and the normal I'm just going to put up here. This is just a rough drawing. 12 3/10. And what is the distance from here to here? How much more is 12 3/10 than 3 2/10? So I need to subtract 3 2/10 from 12 3/10. And these are mixed numbers and I need them to be in proper fractions. So 12/10 is 120/10 plus 3 is 123/10 minus 32/10 is 91/10, and that's 9 1/10 inches. So in San Francisco, the rainfall is 9 1/10 inches less than normal for this point in the season. And I want to point out that I drew a model here. I set up my problem, converted to improper fractions, and when I was done with my calculation, I wrote my units, 9 1/10 inches. So here we have a question where a shark is swimming at a depth of 5 feet below sea level, and then it dove 18 feet further. What is its new depth relative to sea level? So I'm going to draw a model. Here I'm going to have sea level, and we have the shark here 5 feet below sea level. There's my shark, and that's 5 feet, and because it's 5 feet below sea level, I'm going to write negative 5 feet, and then it dove 18 feet further, so it went down another 18 feet, so I'm going to say negative 18 feet, and it's here, it ends up here. What is the elevation here? What is its new depth relative to sea level? So I have the beginning elevation, or beginning depth below water, the beginning depth, the change in depth, and I want to know the final depth. So I'm organizing my information here so I can see clearly what information I have. Beginning depth, negative 5 feet. Change in depth, negative 18 feet. What is my final depth? So I will add negative 5 and negative 18 to find my final depth. And remember, when you're adding two negative numbers, your final answer is going to be negative, because you have 5 negatives and another 18 negatives. How many have under 3, 4, 5, 6, 7, 8, 9? So I'm going to have 23 negatives. And to use the algorithm, I get the absolute value of both numbers, 5 and 18, add them together, 23, and they're both negative, so my sign is going to be negative 23. So I just want to show you on this problem, I drew a model here, and I organized my information here. I did my calculations 2 different ways. I added the negative signs here, and I used an algorithm here. So to summarize, drawing a model to represent a situation can help you see clearly what needs to be done. Organizing the information helps you see what information you are given and what you are looking to calculate. And writing an equation, writing, for example, in the last problem, negative 5 minus 18 represents the situation, and then we can solve this equation. Negative 5 plus negative 18 is equal to negative 23. So you saw how to draw models to represent a problem, how to organize the information you're given. I had beginning depth, change in depth, and then I clarified that I needed to calculate the final depth. Writing equations such as negative 5 minus 18, and then solving these by subtracting or adding rational numbers, and you saw how to write your answer in a sentence. And that's the end of today's lesson.